Every night, while you lie completely still, a hidden system begins washing your brain. A clear fluid moves around its blood vessels, carrying away part of the molecular waste produced while you were awake. But scientists have discovered something unexpected. This cleaning system has two speeds. Near the surface, fluid travels quickly. Deep inside the brain, it moves around 50 times more slowly. That difference could change how we study aging, concussion, and diseases such as Alzheimer's. Your brain consumes roughly 1/5 of your energy. Every thought, memory, and movement depends on billions of cells exchanging electrical and chemical signals. That activity leaves behind metabolic byproducts and used proteins. Other organs rely on the lymphatic system to remove waste, but for decades, the brain appeared to lack an equivalent network. So where did the waste go? The answer is the glymphatic system, a fluid transport process organized around blood vessels and supported by star-shaped cells called astrocytes. Cerebrospinal fluid surrounds the brain and spinal cord. It can travel beside arteries, exchange with fluid inside brain tissue, and help carry debris towards drainage routes. It is not a pressure washer or a set of empty pipes. It is a delicate circulation system threaded through the most complex tissue in your body. And sleep changes how it works. As you enter deeper sleep, slow electrical waves pass through the brain. Blood vessels rhythmically change, and cerebrospinal fluid moves in coordinated pulses. Animal studies suggest that spaces around brain cells become more open during sleep, allowing fluid to pass more efficiently. Sleep is not a moment when your brain switches off. It is an active maintenance state. While you lose awareness of the world, your brain reorganizes memories, regulates chemical activity, and creates conditions that support waste removal. Among the substances transported through these pathways are amyloid beta and tau. Both are normal proteins, but abnormal accumulation is associated with neurodegenerative diseases, including Alzheimer's. This does not mean one sleepless night causes dementia, and sleeping longer cannot cure Alzheimer's. Disrupted sleep may interfere with clearance, while aging and disease can also disturb sleep. But the newest discovery adds another layer. Measuring fluid movement inside a living brain is extremely difficult. The flows are microscopic, and instruments could damage the tissue or alter the process. Researchers combined magnetic resonance imaging with physics-informed artificial intelligence. They tracked how a tracer spread through the brain, then used physical laws to estimate the fluid's movement. What appeared was not one uniform current. It was a two-speed landscape. Fluid moved at a few micrometers per second through open spaces near the brain's surface and around major vessels. But in deep tissue, transport was about 50 times slower and depended much more on diffusion. Imagine water moving quickly around a dense forest, then slowing dramatically as it enters between the trees. That difference matters. Scientists must understand normal circulation before they can recognize when it begins to fail. Aging, disrupted sleep, cardiovascular problems, repeated head impacts, and neurodegenerative disease have all been associated with changes in brain fluid movement. But this technology is not yet a test for Alzheimer's. Much of the detailed mapping still comes from animal research. Scientists must compare healthy, aging, injured, and diseased brains before it becomes clinically useful. Evidence in humans is growing. Researchers have visualized fluid-filled pathways beside blood vessels in neurosurgery patients. Another study monitored people throughout the night and found that this system was not controlled by a simple switch. Clearance-related activity appeared during deep sleep, REM sleep, and the transition towards waking. It accelerated as sleep continued, then gradually slowed as participants awakened. So the claim that your brain cleans itself only during deep sleep is too simple. Sleep is crucial, but the process also changes with brain waves, blood flow, breathing, heart activity, and your internal clock. And this raises one final question. What happens when sleep is interrupted night after night before this maintenance cycle can work normally? Scientists cannot yet calculate exactly how much waste your brain clears in one night. But good quality sleep is not optional downtime. It is part of the biological infrastructure that keeps your brain functioning. Tonight, when you close your eyes, your brain will not become inactive. Fluids will move. Blood vessels will pulse. Cells will change their behavior. And deep inside your skull, an invisible cleaning system will continue working at two dramatically different speeds. You may be asleep, but your brain's night shift will have only just begun.